Right, so in this video, I'm going to be talking about more transformations. Right, so say that we have with sine equals negative x, negative x, negative sine of x. Right, one thing that I want you guys to see is that we have this minus here. Right, and what does this negative do? This is going to be a reflection over, right, the x axis. Remember, coordinate plane, y axis, and this is my x axis. Right, so this is what you guys need to understand. And of course, we could, if we have the form, right, if we have sine of, and then we usually have minus x plus pi, right, this negative right here is going to be reflection over the y-axis. But this is rarer to see because it's very hard to graph it when this happens. Because you're not going to have enough coordinates, right? It's always dependent. It's not, one side of the coordinate plane won't be always proportional to the other one. So that's why you always usually have a reflection over the x-axis over the y-axis. But anything can happen. Right, so how would we do this? Everything will be exactly the same, right? As you know, there's no transformations. We're not horizontally shifting, or vertically shifting. Because what is that? If I had sine of 2x plus pi and then plus d, and plus 3, for example, you know, you're going up 3, you know that this pi right here and this right here will change your x scale, and it's going to change your period, and it's all going to, you know, change everything. But, you know, once you have your starting point, because now this right here is going to equal 0, because we don't have now x anymore, so it's not going to start at 0. This is going to shift to probably a starting point here, and that's how the graph follows on, right? From a new starting point, not 0 anymore. So let's see, if we have this, and you know that you have here, you have 1 and you have negative 1. You know, this starts here, so it's maximum, intercept, minimum, intercept, and this is how this graph looks like. This looks really curved down, and that's it. Right, so this is how it starts, right? And we know this is 0, this is pi halves, right? And there, 0 pi halves pi, 3 pi halves, and 2 pi. Remember, this is how the graph looks. You have your 4 major points. But now we have a reflection. So you can, a simple way of doing whenever you have your intercept is the same. Whenever you have this, just neglect it to here, intercept the same. This one now neglect it to here and intercept the same. So your graph will now be looking like this. Right? Sort of like this reflection. Which one up, there. So sort of this little reflection there. So like what I'm trying to say, like as a formula for reflection, whenever we have a reflection over the y-axis, what we say for our coordinates, we keep, right, this is reflection, so we keep y the same. So our x is going to be opposite of x. Right, it's going to look something like this. Right? And then if you have a reflection over the y, now if you have a reflection over the axis, your x is constant, and it's the opposite of your y. But let me do something. Let me show you representation here, which we're going to get to technology later on. So let's say we have our function sine, right? And then we have sine of x. You can see here, look at the spaces in here, right? You can see that from our parent graph, the starting point is here, right? And then something else that I want to show you guys is that if I add plus, and then let's say pi, you can see that that's shifting it, right? It's now our starting point for sine is here, right? It's not at the origin anymore. And then if we add 2, for example, you can see your graph is now shifted. Your graph has shifted upwards 2 points, right? It's now up. That's what happens. You can create that imaginary new x-axis and then shift 2 up, and then shift 2 up from the origin as well. And then say that this says -2, your graph has shifted down. So this is what your D tells you. Your D, this 2 right here, is going to tell if your graph is going to shift up or down. And then your pi, or your, what we usually see our C, right, BX opposite. Remember, this is always going to be the opposite of C though. It's going to tell if your graph is going to shift left or right. And then say we have sine of, right, here's 1, right? This is like a 1. Same thing with 1. Nothing changes. But if we delete it to like 8, you can see what happens to the graph, the shape, the curvature of this graph changes, right? As it gets bigger, we can see it gets horizontally compressed, right? As let's put this as a decimal. Let's do 0.2. No, sorry, that's too much. Let's do 0.8. You can see this is horizontally stretched in comparison to 3, for example. This is compressed horizontally, right? Vertically stretched, horizontally compressed. So this is basically the concept of these transformations that I'm trying to show you. And of course, right, your period, right, let's do an overall contextualization again. Your period, right, for sine and cosine graphs, right, for sine, before we get to the final stages, because we're starting to go to the conics, and I really wanted to make sure you guys got trigonometry. For sine and cosine, my period is always going to be equal to 2 pi, also 360 for reduced angles. In this course, I'm just going through ratios. It's equal to 2 pi over your b, the standard form of y equals a sine of bx opposite of c plus d. Right, this is your standard form. As you have standard forms, as we talked about, for your linear quadratic graphs. Right, so this is the period. Remember, amplitude for sine and cosine again, because remember, for tangent we don't have one. Is equal to sine again slash cosine. This is going to be equal to 2. Sorry, it's going to always be equal to the absolute value of a. Right, and then our phase shift will always have your function equal to 0, because that's the endpoint for sine and cosine again, right? That changes. And then what doesn't change is my vertical translation will always be equal to d. And of course, my x scale for sine and cosine is my p divided by 4. We know for tangent it's going to be that p halved. But for sine and cosine is fourth. Thank you all. Guilherme de Castro.